Hello friends, welcome to my YouTube channel Aviation. Today's topic of discussion is coordinated turn. This is a very small yet very important topic to discuss about. So let's go to the definition. This video I have made initially the theory part to make you understand what is a coordinated turn, and later on we'll be going to the mechanics of the turn, the physics behind it. So coordinated turn, when aircraft is turning with zero side slip and side skid, that means the aircraft is in a coordinated turn. How the pilot get to know? So there is a turn and bank indicator installed on the aircraft or helicopter, and the ball, if it is in the center of the spirit level, that means aircraft is in a coordinated turn. As you can see in the figure, this is the turn and bank indicator, and this is the ball which is there, as I put the dot, is the ball. So what is happening in the turn and bank indicator? There is a ball at the center. If the aircraft is taking a coordinated turn, there is no lateral force acting on it, and the ball remains at the center. However, in an uncoordinated turn, let's say aircraft is slipping inside the coordinated turn or skidding outside the coordinated turn. This is a true turn. Then there is a lateral acceleration outside or inside, and that's how the ball slip. So if the ball is at the center, that means aircraft is in a coordinated turn. Also, the pilots, they do not perceive any lateral acceleration, which I was talking about, and their weight acting straight downwards. This is how a coordinated turn is made. So what are the advantages of it? It is more comfortable for the pilot and occupants, definitely. Minimum drag on aircraft, because the aircraft is in a coordinated, there is no slipping or skidding, and that's why there is no additional drag adding. The fuel drawn equally from the tank on either wings. Yes, this is one of the important parameters. Last yet important, that minimize the risk of entering uncontrolled flight. So as I've told, this is the true path. The aircraft should turn on this, and the aircraft is slipping inside. There's a chance that aircraft goes into the spiral, and this is skid. So either way, the aircraft is in an uncontrolled flight where the pilot doesn't want his aircraft to be. There are few important parameters, like how the turn is made and what leads to what. So if the pilot is using only the rudder, the airplane tends to skid outside the turn. So as you can see the figure, this is the aircraft trying to make a turn. This is the true path it's supposed to take. If the aileron is only used, if the rudder is only used, that means the aircraft is pushing this side and there is an opposite force, and then the aircraft will tends to go in this manner. As you can see, this is how the aircraft orientation, and then it will skid from the original path, which leads to further problem, which I have already discussed. If the pilot use only ailerons means the controls on the wings, and if the aircraft is just banking, it's not using any rudder or elevator, the aircraft will leads to slip. So this is written, the plate in ailerons, airplane tends to slip towards the lower wing. This is the lower wing, and this is how the aircraft will go. So either case, aircraft, the pilot should not be only using rudder or only ailerons. So using appropriate rudder and ailerons along with the elevator to adjust the lift, the pilot enter and leave the turn without any lateral acceleration, and thereby avoiding side slip or skid. So I hope you understood this part. This is the theory part, and this is the figure. As you can see, in a level flight, the lift and weight both are equal. There is no turn. As the aircraft gets into the turn, the banking of the aircraft, the component gets changed. So we'll be discussing about the mechanics of the control turn now. So in this, bit of a trigonometry will come. So as we are aware, there is a total lift as the aircraft bank. So lift will be acting as a perpendicular to the wing. So this is the wing. The weight is acting downwards. There is a centripetal force which is acting inside. So force we know is equal to m into centripetal acceleration, and centripetal acceleration is v square by r. So we'll write centripetal acceleration is v square by r, and centripetal force will be equal to mv square by r, which can also be written as wv square by rg by multiplying g at the top and at the bottom. So this is the centripetal force, which is wv square by rg. I hope this much is clear, correct? And then there is a vertical lift which is equal to the weight, lift vertical, and this is lift horizontal. So this is the banking angle. Let's say theta is the bank angle, is the correct bank angle, and when we equate, it will goes like that. Tan theta will be equal to wv square by rg by w, that is the perpendicular by base. So this will cancel out and it will become v square by rg. So this is formula 1, which is tan theta is equal to v square by rg, and formula 2, which is important, which is cos theta, which is equal to the perpendicular upon hypotenuse, which is W by L, or it can be written as lift is equal to W by cos theta. So this is the formula 2. So both these formulas are very important and we'll be discussing each one of them now. So first the second formula, that is L lift which is required to be generated is equal to W by cos theta during a turn. So we know about cos theta and tan theta. I have put a table here, and we know that cos theta is highest at 0 degree and at 90 degree it is 0. So at 0 degree, when there is no bank angle, when theta is 0, no banking, straight and level flight, the lift is equal to weight. However, if we increase the bank angle from 60 degree to 84 degree, the weight, because cos 60 is half, and the lift which is required to be generated will become two times the weight. And at 85 degree banking angle, the lift required is approximately 10 times of the weight. So it is very important to understand that what is the maximum bank aircraft can do, which can support the structure to generate that much lift. Because lift 10 times the weight generation of the lift required, the structure might fail. So this is one important parameter. And second is formula 1, which is tan theta is equal to V square by Rg. Here are three parameters: theta, that is bank angle, velocity and the radius. So we can understand using this figure. So when an aircraft is banking, let's say it has a radius of turn. So how much bank angle it should make, which is further being guided by lift is equal to W by cos theta, and what should be the velocity. So if the aircraft is making a tighter turn, let's say theta is high, the velocity is also required to be high, because theta and velocity are directly proportional to each other, and the radius of turn may reduce. So in case of fighter, the velocity is very high and it can take a sharper turn, tighter turn, and the radius of turn is reduced. However, in the commercial flight, the bank angle is not much, the velocity is somewhere okay, and the radius it can increase. So tan theta and the radius is inversely proportional to each other, and the velocity and theta is directly proportional. So all three should balance to each other. So here I conclude my video about the coordinated turn. If you have any query about this video, let me know. Please subscribe to my channel, share it to your friends and family, and all those who are aviation enthusiasts. Let's make the aviation easy. Thank you.